So the final question on the test, it has 4 different parts, and it's all about equations of lines, linear equations. Again, these are just like arithmetic sequences, except the big difference is when you're looking at the equation of these lines, the equation of the line has a domain that's basically all real numbers, and when we're looking at the arithmetic sequence, our domain is restricted to the natural numbers. So it starts at the number 1 and then jumps to 2 and then to 3 and to 4 without getting the numbers in between. But other than that difference in the domain, right, an arithmetic sequence and a line have all the same attributes. So this first one is it says write the equation of a line with a slope of -1/2 and a y-intercept of 3. So you can think about this as like this is the 0th term, right? It's starting out at 3, and every single time it's decreasing by 1/2. So you're subtracting 1/2 each time you move forward. Well, that slope, right, that what you're going down by each time, we write the equation as line y equals -1/2 times x. Remember, this multiplication by x, multiplication allows us to show repeated subtraction of a half. So you're either subtracting no 1/2 or 1/1/2 or 2 1/2 or 3 1/2, etc. And then plus the 0th term, which is 3. So you know y equals mx plus b. The next one says, write the equation of a line with a slope of 3/7 that passes through the point 7, 8. So the thing that we've been doing repeatedly both semesters is if we look at this point, it's got an x and a y. It contains an x and a y, and we also know the slope. So if we consider the equation of a line in this form, y equals mx plus b, well, we know a y, right? The y value we know is the number 8, so we can write 8 in for y. We know the slope is 3/7, so we could write that in for m. We know that our x value is 7, right? You can see here's our x, it's the number 7, so we can write that in for x. And then plus, the only thing that we don't know is we don't know what the y-intercept is. That's the beauty of doing this. At this point, I have an equation in which my y-intercept b is the only variable, so I just solve. And if you're not sure, how to simplify this, remember this is 3/7 times 7, so you could say 7/1. And if you rewrote this a little bit, right, it's 3 times 7/7. You can see this giant 1. So this should just be the number 3. Also, you can verify that with your calculator if you'd like, right? 3 times 7 is, of course, 21, and then 21 divided by 7 takes us right back to 3. So this entire thing is just a 3, and over here is the number 8. And in order to get b alone, we're just going to subtract 3 from both sides. So b, our y-intercept, or our 0th term, is 5. So using this information together, we can write the full equation of the line. Y equals 3/7 x. This is increasing 3/7 each time x increases by 1. It has a slope pattern up 3/7, and we have this y-intercept at 5. Okay, last 2 parts here. The next one is a line that goes through, and they give us 2 points. So actually it's a lot like the previous 2 questions. It's just now they give us even less information each time. We do know that the slope of a line, right? I don't want to write that in red. We know that the slope, S-L-O-P-E, of a line is a ratio between 2 numbers, right? It's the change in the y values divided by the change in the x values. And if you look up here, I've got a couple x values. Here's an x and here's another x. And I've got a couple y values. Here's a y and here's a y. So with my 2 points, I've got an x and a y in each case. So I just need to find the differences between y's and divide by the differences in the x's. The only thing that, it's important to remember the order in which you do the subtraction. It doesn't really matter as long as you're consistent. So what I'm going to do is I'm going to start at this point and then go to here. So I'm going to say, what is -4 minus 2? That's the change in my y's. And then I'll do the same thing for my x's. I'm going to go +4 minus 1. So I'm going to have a 4 minus 1. So you can see I'm moving from this point on the right to the point on the left. And if you were to flip it, you would get the exact same answer. It's just your signs in the top and bottom would be reversed, but they would cancel out and it would be equivalent. So in my numerator here, I have -4 minus 2, which looks like -6. So I've got -6. And my denominator is a +3. And -6 divided by +3 is a slope of -2. So I now know the slope of my line, right? My slope is -2. And I also know 2 points, and I'm just going to arbitrarily pick one of them. It doesn't matter at all which one. I'm going to pick the point 2, 1. So if you look at this, I've got an x and I've got a y, and I also have the slope of -2, right? So I'm just going to do the exact same thing I did in the previous problem. I'm going to write down this y equals mx plus b. That's the equation of a line in slope-intercept form. I've got a y value of 2. You can see it right here. I've got a slope of -2. It's right here. I've got an x value of +1. It's right there. And then plus b. So if I simplify this, this is looking like 2 equals -2 plus b. And if I add 2 to both sides, I get that b has to be the number +4. So I now know both the slope and y-intercept, so I can write the equation of this line. The line is y equals -2, and then times x, and then plus the number 4. And, you know, a couple of ways, probably the best way to verify that this solution works on a test is to grab your calculator and make sure that when you plug in these points, you're getting something that's true each time. So for example, if I take this point x is 1 and y is 2, and I plug that into this equation, it should make both the left and right hand side the same. So let me take my x here of 1. I'm just going to say -2 times 1 plus 4. When you can do that, you can see it gives me 2 as the answer, which is what it should give me. So it works. And if I put in that x is 4, it should give me -4 for y. That's the other point that I had right here. So again, let me plug that in. -2 times 4, and then, oops, -2 times 4, and then plus 4. And it should give me, plus 4. It should give me, and it does give me -4. So again, that works. Another thing that's nice to do is to remember what it is we're actually accomplishing here. So if I was to grab GeoGebra and plot both of those points, here they are. One of the points was at over 1 up 2. The other point was over 4 down 4. And our claim is that this line, let's see, the equation that we got was -2x plus 4. So I could type into the input bar down here y equals, let's see, y equals, and then I need -2x and then plus the number 4. So y equals 2x plus 4. And as soon as I press enter, you can see it put the line in the screen there that goes exactly through points A and B. So this is exactly the line we're looking for. All right, the last question we've got here is D. Whoops. So hopefully I can do this one without making any mistakes, and then we'll get a straight run through this without having to re-record anything. A line is perpendicular to this line, y equals -3/2 x, and then plus 8. And it goes through this point 3/4. So perpendicular to this line, and it goes through the point 3/4. And you know, I just want to reference the last problem we did and look at what happens when you rotate a line 90 degrees. If you look at this slope right here, this one was down 1, 2, 3, 4, 5, 6, down 6 over 3, which was -2, right? Down 2 over 2, down 2 over 2, down 2 over 2. So I could down 2 over 1. I could make a smaller slope triangle, but I'll just keep this one. But what happens is if I do a 90-degree rotation, let me grab my rotation tool. So I'm going to rotate, let's see, what does it say to do? It says select object to rotate, then the center point, and then enter the angle. So I'm going to rotate this object around this point, and I'm going to do it for 90 degrees counterclockwise. That's fine. But when I do that, notice what happens. What was my run, right? What was my run becomes the rise. So I was going to the right 3. Now I'm going, up 3, right? And then my rise becomes the run. So the run becomes the rise, and this rise becomes the run. So when you rotate, right, and the signs do change, right? This has a slope of positive 2, or I'm sorry, positive 1/2. It's up 1 over 2, up 1 over 2. This has a slope of negative 2, down 2 over 1, down 2 over 1. So what happens when we rotate through 90 degrees is we end up getting slopes that are opposite in sign and reciprocals from the slope that we were given. So that's just by way of visual review. So if I want a line that's perpendicular to this line, I need a slope that's positive 2/3. So anytime that we have perpendicular lines, I'm taking the opposite reciprocal to figure out what the slope is. So I'm trying to find basically a line that goes through the point 3, 4 and has a slope of positive 2/3. That's pretty easy, right? Y equals mx plus b. Again, I've got an x value, I've got a y value, and I've got a slope. So I'm going to put down, y is 4, and that equals my slope 2/3, and then times my value of x, which is 3, and then plus b. Well, 2/3 times 3, 2 times 3 is 6, 6 divided by 3 is 2. So this just becomes the number 2 plus b, and then I've got 4. If I take away 2 from both sides, we get that b, my y-intercept, is 2. And we still know our slope. It's right up here. So the equation in line for this is y equals 2/3 x, and then plus, not b, plus 2, our y-intercept. And that's the final question from the study team test.